Today's presentation is going to cover the first part of section 8.5, which is the properties of trapezoids. So we're going to talk about this green part of this diagram. So there's two types of trapezoids: regular trapezoids and isosceles trapezoids. We're going to talk about those all today. So what is a trapezoid? So a trapezoid, by mathematical definition, is a quadrilateral that has exactly one pair of parallel sides. So parallelograms have two sets of parallel sides. A trapezoid has just one set, and that set of parallel sides we call bases. So you'll notice here that these two here are the bases on this trapezoid. These two are the bases on this trapezoid. And then down here, these two are the bases on this trapezoid. And over here, we don't have trapezoids. This has two sets of parallel sides, so this is not one. This also has two sets, so that's why it's not one. And then over here, we don't have anything marked parallel, so that's why this one is not. So some properties of trapezoids, and this can be a little bit confusing. Trapezoids have two sets of base angles, and you're going to be like, well, wait a second. If it's a quadrilateral and it's got two sets of base angles, this is a set, so that's two angles, and then down here is a set, and this is two more angles. That means it's got four angles. That means every angle is a base angle, and it is and it isn't. So I guess I really get concerned about students screwing that up, and you'll notice I screwed up here on purpose to be funny. Yes, Mr. Kenyon is super funny. But in order to be a set of base angles, you have to share a base. So these two angles here are base angles because they share the top base, this parallel side here. And then these two angles down here are base angles because they share the bottom base with this parallel side. So these are not base angles going up and down here, and these are not base angles going up here. So the bases are the parallel sides. The base angles share a parallel side. And then, there's two other sides to a trapezoid, and those two other sides to a trapezoid are called legs. So that's where you're like a trapezoid. You have two legs, and trapezoids have two legs. So they have two sides called bases, and they have two sides called legs. So here's a special trapezoid. This is the isosceles trapezoid. And I've referred to it in previous years as a princess trapezoid because it's very special. It's kind of regal or royal. It's got some really cool characteristics. And the cool characteristics about it is that it's got exactly one set of parallel sides and exactly one set of congruent sides. So the legs are congruent and the bases are parallel. So this is a leg here, and then over here on this side is a leg, and those are congruent to each other. And then our bases on the top and bottom are parallel. Now, you can't have a set that does both at the same time. So I can't have the bases also being congruent to each other, and I can't have the legs parallel to each other, because if you remember, that's one of the characteristics of proving a parallelogram is having a set of sides that are congruent and parallel. So a trapezoid, that has to be separate. So the legs are the ones that have to be congruent, and the bases are the ones that have to be parallel. A couple of other things that are kind of unique about the isosceles trapezoid. First of all, the diagonals are congruent to each other. So just like on a rectangle, the diagonals are congruent, or a square, an isosceles trapezoid has congruent diagonals. All right, and then the thing that's also unique about the isosceles trapezoid is that the base angles are congruent. So these top two angles are congruent to each other, and then the bottom two angles are congruent to each other. So the isosceles trapezoid is a pretty neat figure. It does a lot of cool things. So let's take a look at trying to figure out the missing lengths here. So first of all, we want to know what kind of quadrilateral it is. So this is an isosceles trapezoid. I've got the bases marked parallel, and I've got the legs marked congruent. So in this case, the measure of angle H here at this corner is 70 degrees. So to find the measure of angle HEF, which is this angle right here, so to find the measure of that angle, that is going to be kind of like alternate interior angles, because they do have parallel sides here, and alternate interior angles are going to be supplementary. So this angle is going to be supplementary with angle H. So the measure of angle HEF, this yellow angle here, is going to be 180 minus 70 degrees. So this is going to be 110 degrees. And then because this is an isosceles trapezoid, the diagonals are going to be congruent to each other. So segment EG and segment HF are going to be congruent to each other. And that's how we do this problem. All right, so here we want to find x. So what is x right here? And we know the perimeter of this entire figure is 87 inches, and we notice this is an isosceles trapezoid. The bases are parallel, the legs are congruent. So all I need to do is take my total perimeter, which is 87 inches. I'm going to subtract the 20 inches here. I'm going to subtract the 39 inches here. And when I subtract 59 inches from 87 inches, that's going to leave me with 28 inches. And because this is an isosceles trapezoid, the legs are going to be congruent to each other. So I take 28 inches and I divide that by 2, and I get 14 inches. So this length right here is 14 inches. And then over here, this length here as well is also going to be 14 inches. So both of these are going to be 14 inches. And that's how we do this type of problem. All right, so let's take a look at this one. Again, we've got another isosceles trapezoid. We'll notice this angle is 138 degrees, which means the measure of this angle x, because it's a base angle, is also going to be 138 degrees. So x is going to be 138 degrees. Really not any work to do other than recognizing the figure. And then because these two angles here are going to be supplementary with each other, again, they're like alternate interior angles, I take 180 degrees, subtract 138 degrees, and that's going to leave me with 42 degrees. And that's how we solve this type of problem. All right, another concept from this section is midsegment. Now, if you remember from triangles, triangles had 3 sides, 3 angles, and 3 midsegments because that connected the midpoints of all the sides of a triangle. On a trapezoid, there's only one midsegment, and that midsegment is the average length of the bases. So if I take this base at the top and add to that the base on the bottom, take those two numbers and add them up and divide by 2, that's going to give me the length of the midsegment. So the midsegment is equal to half the length, or not, sorry, not half. The midsegment is equal to the average of the length of the bases, and then it's also equally distant between the bases. So the distance from here to here is the same as it is from here to here. So if you take the midpoints of your legs and connect them, that's going to create a midsegment. Now, I kind of got into that before when I sort of said half. If I take two numbers and cut them and average and cut them or average them, I add them up and I cut them in half. So if I take the average of the two bases, I need to divide by 2. So if I wanted to find the average of these numbers here, I would basically take 6 plus 4 to get 10, add to that 9 to get 19, add that 5 to get 24. And because there's 4 numbers here, I would divide by 4. So 24 divided by 4 would be 6. That's just the concept of finding the average. So in taking a look at these two examples here, if I want to figure out the length of this midsegment, I'm going to take 10 and 14 and add them together. So 10 plus 14 is going to be 24. And then divide that by 2. And that is going to be 12. So the length of this midsegment here is 12. Now over here for this type of example, I actually use a trick. So the mathematical formula would be y plus 28 divided by 2 equals 23. But I don't do that. Instead, what I notice here is I notice that going from 28 to 23, I'm going down 5 spots, or 5 lengths, 5 inches, whatever amount this is. And because this is equally distant between here as it is in here, I'm going to subtract that equal 5 from my midsegment and get 23 minus 5 to get 18. So that's the trick I use to solve this. So take equaling amounts difference between this number and that number and apply it to this number, and that will get me my ending number here. Right? So basically the same deal here, except the difference is we're adding in this case. The previous example we were subtracting, but in this case we're adding. So going from 10 feet to 20 or to 36 feet is a difference of 26 feet. So if I just take 36 minus 10, I get 26. So that's the difference between these two. I need to apply that same difference to my mid-segment to get my ending base. So I'm going to take 26 and 36 and add that together. And that's going to be 2, and that's going to be 62 feet. So the length of this base is 62 feet. All right, so that takes us through the first part of section 8.5 where we discuss trapezoids. Your assignment for Wednesday is on page 540 to do 1 and 7 through 12. Don't send that to me right away, just hold on to it. And then on Thursday, I want you to do page 540 through 541, questions 13 through 16, and 24 through 25. When you get Thursday's assignment done, then you can send both of them to me in a new email. And hopefully you have a great rest of your day. Thanks for watching the presentation.